Okay, so now ladies and gentlemen, let's look at what we have started. This is a box containing a gaseous molecules, and each of these gaseous molecules have mass and velocity. And so also what I want you to understand here is, remember, as we said, that the molecules in the container collide with one another and also with the wall of the container, and the collision is perfectly elastic. So each of the molecules in the container have mass and velocity. Mass is represented with small letter m and velocity is represented by c. So let's say these molecules move in x direction, and we said that these molecules have mass and velocity, so it means that it is easy to get their momentum. P here represent momentum, so momentum is equal to mass times velocity. So if it moves in this direction, we have momentum is equal to mc. We can use x because the velocity is at the direction of x. Then if these molecules strike or hit the walls of the container, it will rebound back. So therefore our momentum will now change to be minus mcx. So to get the change of momentum, then we now have mcx minus, open bracket, minus mcx, then close bracket. Then our now change of momentum is equal to mcx minus times minus is plus, and we have mcx. So now we have change of momentum is equal to m2 mcx. So what of the rate of change of momentum? If we say the rate of change of momentum, so it means that we'll end up of having something like this: 2 mcx. Remember, whenever we say rates, it means time, so it means that divided by t. And remember, from our basic physics, velocity is equal to displacement. Here L means displacement all over time, so this L here means displacement, and the T here means time, and C here means velocity. So now we can now make 1 all over T subject of the formula. So now we can now say C is equal to L times 1 all over T. Then divide both sides by L. This one will now cancel this. Therefore, we now have 1 all over T is equal to C all over L. So mean that wherever we have 1 all over T, we can replace it with C. So now we can now say our rate of change of momentum, is equal to 2 mcx times 1 all over T. So now we can easily replace 1 all over T with C over L in this equation. So therefore now we have 2 mcx times C all over L. So we can now say our C also is in x direction, so we can now put x here. Therefore now we have 2 mcx square all over L. So we now have this. Do you understand? Then now we will now move to see that since we are talking about the rate of change of momentum, so remember in physics, when we said the rate of change of momentum is directly proportional to the force applied. This is the Newton's second law of motion. So therefore it means that, remember, according to the Newton's second law of motion, the rate of change of momentum is directly proportional to the force applied. So therefore now we can say now is the same thing to say force is directly proportional to the change in momentum. That is the rate of change of momentum. So therefore now it means that wherever we have the rate of change of momentum, we can replace it with force. So now we can now say force is equal to 2mcx square all over L. That is this. So now what is the next thing? Remember, pressure in physics is equal to force all over area. So therefore we can now make this F subject of the formula. Therefore we can now say F is equal to pressure times area. That is this. Then therefore we can now replace F with this PE. So therefore you can now say PA is equal to 2mc square. You can even just remove that x. So 2mc square all over L. And remember, the area of a cube, the area of a cube is equal to 6L square. That is the area of a cube in mathematics. So now what next? We can now replace this A with 6L square. So P times 6L square is equal to 2mc square all over L. So since we have L here, we have L here, we can say L square times L. Then we have P times 6L cube is equal to 2mc square. So we can now say divide both sides by 6 here, the 6 we have. So this one will now cancel this. Is that clear? So now we have something like this. P times L cube is volume is equal to 2 into this we have 1, 2 into this we have 3. So we have so now we have mc square all over 3. So this is pressure times volume is equal to mc square all over 3. Then now the next thing is this. Since we have PV is equal to mc square, and remember, if the number of molecules is more than 1, So we can now have PV is equal to N mc square all over 3. So we can now make this C subject of the formula. So which is something to say cross multiply. So we have 3 PV is equal to N mc square. So divide both sides by N m. Here also N m. This one cancel this. So we have C square is equal to 3 PV all over N m. So we can now say square root both sides. This one will now take care of this. So we now have C. This C is root mean square speed here. So you can now say root mean square velocity is equal to square root of 3 PV all over Nm. So this is the formula for calculating root mean square speed. But remember, ideal gas equation is PV is equal to nRT. So but look at this here. We know that N is equal to mass all over molar mass. So if our number of moles is 1, then we can now say PV is equal to RT. So now we can now see root mean square speed is equal to, we can replace PV with RT. So therefore you can now say square root of RT all over N. Okay, sorry, we have 3 here, so 3 RT all over Nm. So this is the formula for calculating root mean square speed. So also at the same time, you can also come back to this and drive at something else. Remember, in physics, density rho is equal to mass over volume. Is that so? So but we can now say that we can now take the reciprocal of density is equal to volume all over m. So now look at this from here, from this formula. We have V over m. V over m is equal to 1 over density. So we can now remove this V over m and say that we have 3P all over N times density. So this one is also a formula for calculating root mean square speed. Pressure all over number of molecules times density. So thank you for listening. From this general equation, we'll follow it to derive a lot of equations like Boyle's law, Charles' law, Graham's law of diffusions, and Dalton's law of partial pressure. Thank you.